Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Stellar Cores Absorb Photons which Carry Gravitational Energy. Now, in the late 1970s and early 1980s, Dr. Robert Harrington went in search of what he called Planet X. And it's likely that he found it as he ended up dying under extremely suspicious circumstances, which suggests that he was killed in order to keep what he found a secret. And it is also likely that what he found was at least one of the objects, which I usually refer to as stellar cores, and that I have now been observing in the sun's corona for many months. Some of these objects must have been in the solar system already. That is at the time you went looking for Planet X, as there is evidence that they started coming in about 160 years ago, or from about 1850. And this is about the time that noctilucent clouds appeared for the first time, and also about the time that the Earth's magnetic field started weakening. And here we see some images of these objects. We can see one here. We can see the connection it's making with the sun. We clearly a spherical object there. Here's another one. These are STO images. And here's one. This is actually a telescope image. This was taken by Scott Sion through his own telescope. And what we see here is what we call the blue stellar core. It's obviously in the sun's corona. You can see the sun's corona going out to cover it. And it was a huge object. Seemed to be about 1/3 the size of the sun. And we can see that it has material clinging to its surface, obviously a spherical object. It was actually shedding some of this material. And we see another one here in a cactus image. Obviously a spherical object within a CME. And we see some of this material is always seen around these stellar cores. This seems to be part of the material that they are shedding from this surface. Now, it's become obvious to me that these objects have not just been captured by the sun, but also by the Earth. And it seems likely that one of these objects was captured by the Earth at about this time, about 160 years ago. But the object was not visible initially, nor were its effects felt, or perhaps we've captured more in the meantime. But it seems that as these objects invaded the solar system, they possibly not just go to the sun or been captured by the sun, but they were captured by other planets and started affecting the other planets. So this object was not visible initially, but it must have started affecting the Earth's ionosphere in order for noctilucent clouds to appear for the first time. They were never observed before 1850. So this suggests that one object, or perhaps a small one, perhaps a portion of one, since we see that they seem to eject pieces from the surface, was captured by the Earth and possibly started drawing particles from the Earth's Van Allen belts, and thus started reducing the Earth's magnetic field. And this is because most of this field is generated from currents of charged particles coming from the solar wind. These currents are aligned to the Earth's permanent magnetic field in the Earth's core and outer mantle and crust. And this is detailed in an article I've written recently. You can see it in the references. So we often see these stellar cores within CMEs, and this has indicated to me that they possibly actually provoke the sun into having these CMEs. And now it's become possible for me to understand why this is happening once I realized what the interactions are between these objects and the sun. And it's basically two interactions balancing each other out. It's the electrostatic and the gravitational. And here we see the Earth's Van Allen belts. The inner one contains protons, the outer one contains electrons. And this is the structure that we see all over the universe, from atoms to stars to planets. They all have an inner layer which is positive, made out of protons, and an outer layer which is made out of electrons. So this structure all over the universe led me to understand that gravity is not just attractive, it is also repulsive. It causes the separation of positive and negative charges, that is, of protons and electrons, which is why we can have the structure that we have in the universe, why we can have atoms. If it wasn't for this charge separation interaction, which is part of the gravitational interaction, we wouldn't have atoms, and therefore we wouldn't have life in the universe. So with the understanding of what gravity is and the fact that the sun and thus all stars emit light and produce solar wind and CMEs, which are matter creation events, as a result, and they do this as a result of an electric potential difference between their central core and their outer negative layer, and that's the electron layer. And this is generated by the gravitational interaction. And then it becomes possible to understand how stellar cores are drawing energy from the sun. The gravitational interaction causes protons to strongly attract each other, and we see that illustrated here. This is the strongest part of the gravitational interaction. The other part is the repulsion of the proton between the proton and the electron, and this is the charge separation part of the gravitational interaction. And then this causes protons to accumulate and be at their densest in the star's core. And then because positive and negative charges are separated, there will be an outer negative layer around the star. And the same thing would happen with a galaxy or a planet. So it becomes apparent that a star's power source is its gravitational potential energy, because it's that makes this interaction, both the attraction between protons, which makes its core dense, and the separation of protons and electrons, which puts an outer layer on the outside of the star. And so this gravitational potential energy is obtained by the star at the time that it is created by the nucleus of the galaxy it is a part of. So each time that the star creates matter, either to feed the solar wind or produce a solar flare or CME, it uses some of this gravitational potential energy. And in fact, the production of light requires the use of gravitational potential energy, as the photon is the carrier of gravitational potential energy. The creation of light requires either that electrons be captured by an atom, move from a higher energy level to a lower one, or charged particles need to be accelerated. And all of these processes require gravitational potential energy to decrease and that energy be given off as a photon. In the same way, an electron can absorb a photon and thus gain enough gravitational energy, which causes its repulsion to the protons in the core to increase to the point that it may leave the atom or the outer layer of a star. A star has a dense inner positive core, which we can see here as the dark red, and then it has layers that are less dense around that, so it's less and less dense as we move out towards the surface. And then at the edge it has this negative layer, which contains mainly electrons. It's thus just like an atom. So we can say that a star is a superatom. And here we see illustrated again the gravitational interaction, which causes protons to attract protons. And this is the strongest part of the gravitational interaction, which is why we always have the inner core of things being dense and made out of protons. If the interaction is not strong enough in the other part, which causes electrons to be separated from protons, because the gravitational interaction causes this repulsion between the two. And if it's not strong enough, then the electrostatic attraction between positive and negative charges will cause a proton and electron to combine and form a neutron. And then these neutrons can join in the nucleus. The interaction, I think the attraction is not quite as strong between protons and neutrons because of the electron, but because it's very close and protons are very strongly attracted when they're very close to each other, then I suppose it will be nearly as strong. But even then, we can sometimes get an electron exiting the nucleus. This is called beta decay, and this is because of that gravitational repulsion between protons and electrons. Then, because charges are separated by the gravitational interaction, what we may have a nucleus forming. This one has 3 protons, so it's lithium, and then we have electrons which are trapped in a region outside the atom, and they are trapped because there are 2 forces acting on them which have to be in balance when they are in this region. And this is the gravitational interaction, which is represented by green arrows, and the electrostatic interaction, which is represented by the orange arrow. The electrostatic interaction causes the electron to be attracted to the nucleus, which is positive, negative and positive attract, but the gravitational interaction causes these two to separate. So it causes a repulsion between electrons and protons, and when these two are in balance, then that will be when the electron is at a certain distance from the nucleus, and that will then define the region where they will be trapped by these 2 forces. And this is why electrons are outside the nucleus of an atom. Now, since a star is a superatom, an electric discharge requires that its electrons move closer to the core, protons move outwards from the core, and both of these currents require that particles lose gravitational potential energy, which is given off as a photon. So, in other words, just like in an atom, if an electron moves inwards towards the nucleus, it has to lose gravitational potential energy. It cannot be as repelled by this proton as it is here. So it has to lose gravitational potential energy. In other words, it has to do the reverse of what we see here. It has to give off a photon so that it loses energy, so that it can come closer to the nucleus. So we see that there has to be energy given off in order for these currents to flow. And the same thing happens. So whenever there's acceleration of charge, that is, charge moves either, the electron moves inwards, the proton moves outwards, and this is always accompanied by the giving off of a photon. And thus, it seems that acceleration of particles leads to the creation of photons. And then photons split into protons and electrons. And so this is how matter is created. They are actually inside the photon, these 2 particles, and when the photon moves through a region of electric field, and we usually have a region of high electric field close to the surface of a star, and so in that region the photon splits into its constituent particles, which are the electron and the proton. And then the protons are attracted by other protons, so they may actually move back into the center of the star, or because that region is usually filled with electrons from the sun's outer negative layer, these will cause a repelling force on the proton. So it will either move towards the surface of the star, it will be ejected outwards into space from the sun's corona, whilst the electron will not be repelled in this way by the charge separation interaction, and it will be retained by the layer. Now, the fact that photons are carriers of gravitational potential energy and can impart this energy to particles and therefore to stars explains why the 2007 stellar core went from emitting light from its outer layer to becoming increasingly darker as it approached the sun, suggesting that it was absorbing energy. The star was absorbing energy in the form of photons, which were imparting gravitational potential energy to it. And we see the object here in 2007 core. These are stereo B core 2 images from February of 2007. You see the object as it approached the sun. It was emitting light from the side opposite to the side where the sun was. The sun was on the opposite side. So this was not reflection of light, but the object seemed to emit less and less light as it approached the sun. You can see it's getting closer and it's getting darker. Look how dark it is there. And this always suggested to me that it went from a light emission mode or energy emission mode initially far away from the sun, and as it approached the sun it went into light absorption mode and it became dark. Now, the 2007 stellar core did not have a comet's tail, which indicates that it did not draw current from the solar capacitor like comets do, but it was emitting light from its outer toroidal shaped layer. We can see here in this image it seemed to have a toroidal shaped layer around it, which suggests that there was an electric potential difference across this layer, which allowed it to have electric discharges in it. So it must have had an inner layer of protons and an outer layer of electrons. So this layer must have had an inner layer of protons and an outer layer of electrons to cause this potential difference across the layers, which then would lead to discharges and light emission. Now, there was no electric potential difference across the core that would allow it to emit light, because the core, as we can see, remained completely dark during the time that it was observed near the sun at this time in 2007. Now, surfaces on Earth which are exposed to the sun seem to have an absorption and emission mode. During the day, a concrete wall exposed to the sun remains cool on the inside and throughout the day. But once the sun sets, it will seem to give off heat. The wall is actually in energy absorption mode when photons were available during the day, and energy release mode when they are no longer available or at night. So in conclusion, stellar cores absorb photons, which are carriers of gravitational potential energy, which allows them to eventually start emitting light. The next article will explain in more detail how stars evolve into stellar cores and provide a possible explanation of why they are able to hover inside the sun's corona. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.